Hi, welcome to Marker Board Videos. Today's video is about conservation of momentum. So before we get into the conservation of momentum piece, I just want to tell you what we're going to talk about. We're going to talk about what we've talked about all the time. We're going to focus a little bit on Newton's second law of motion, which is force is equal to mass times acceleration due to gravity. And in Newton's second law of motion, we said that in order to accelerate something, you need to exert a force on it. Well, we're going to say the exact same thing, but we're going to use different words. We're going to say to change the momentum, you need to exert an impulse on something. But I want to remind you that external forces are required. Remember we talked about pushing on the dashboard of a car when you're inside of a car doesn't make it move because that's an internal force. We're talking about external forces. So internal forces cancel out, but external forces are required in order to cause acceleration. We're also going to put in Newton's third law of motion. Newton's third law of motion is the action-reaction piece. And if you'll remember when we talked about action-reaction a little bit, we talked about the fact that if you were shooting a gun, that the bullet went in one direction, the gun went in the other direction. Or we can use the Mythbusters example of a cannon. If you have a cannon at rest and a cannonball shoots out of one end, the cannon actually moves in the opposite direction. And if you measure the velocities of those objects, you can figure out the total momentum of the system. Okay? So momentum, just a reminder, also is a vector quantity, which means that it requires magnitude and direction. So it makes a big difference if it's going forward or backwards, up or down, left or right, north or south. Momentum is a vector quantity because it involves velocity, and velocity is a vector quantity. So that really makes complete sense. So the momentum of a system can't be changed unless it's acted on by an outside force. That should sound really, really familiar to you. We've talked about that over and over and over again with Newton's laws. But remember, you have to define your system. So if you forgot how to define a system, go back and watch the video on defining a system. Momentum of a system can't be changed unless it's acted on by an outside force. And when the momentum of a system does not change, we say that momentum is conserved. And it's not just momentum we talk about as conservation. There's lots of things, conservation of energy and conservation of mass, and as we go through, you'll see we use that word quite a bit, but conservation just means the amount stays the same, the total exactly the same. So here then is the actual law in itself. It says, in the absence of an external force, the momentum of a system remains unchanged. So the sum total of the momentum before and after has to be exactly the same. It can't change. The only way it can change is if you've got external forces being involved. But we're saying in the absence of an external force, that momentum before and after, identical. And I'm going to show you in just a little bit about collisions and how that applies.